In this video, we'll be discussing about one of the very important applications of regression in the stock market, which is well known as market model. Financial experts have usually argued that there are two primary goals of investing. Number one, maximizing the expected return, and number two, minimizing the risk. We know that variance or standard deviation are used to measure the risk associated with investment in any stock. Here, we are presenting market model which assumes that the rate of return on a particular stock is linearly related to the rate of return on the stock market index such as Sensex or Nifty. Market model is a model of stock returns that decomposes influences on returns into a systematic factor as measured by return on broad market index, which we call as beta coefficient, and firm specific factor, also known as non-systematic risk, measured by coefficient of determination. We'll be discussing about the calculation and interpretation of these two terms in the video ahead. Before we discuss the market model, let us recall our understanding about regression analysis. We know that the regression model is y equal to beta naught plus beta 1 x plus epsilon. Here y is the dependent variable, beta naught is the y-intercept, beta 1 is the slope of the regression line, x is the independent variable, and epsilon is the error variable. We can represent this model graphically as shown on the screen. Please note that here beta naught and beta 1 are population parameters, which are generally unknown and therefore are estimated from sample data. From the sample data, we estimate y-intercept beta naught using b0 and slope beta 1 using b1 from the least square or regression line given by y hat equal to b0 plus b1x. So the market model is based on the regression model that we just saw. Here you could see that we have written R in the place of Y and Rn in the place of X. Here R is return on any particular stock, while Rn is return on some major stock such as BSE Sensex or NSE's Nifty. The coefficient beta 1 is called the stock's beta coefficient. Using sample data from stock market for a particular time period, we could estimate beta naught and beta 1 with b0 and b1 as shown here, which we also call as sample regression equation, which is R is equal to b0 plus b1 Rm. The coefficient beta 1 here is called the stock's beta coefficient. It measures how a stock is sensitive to the fluctuations of overall market. For example, a particular stock, how it behaves vis-a-vis the movements of the overall market. So if beta 1 is greater than 1, the stock's rate of return is more sensitive to the changes in the level of the overall market than is the average stock. For example, suppose that beta 1 is equal to 2, then a 1% increase in the index results in an average increase of 2% in the stock's return. Or in other words, if the index would go down by 1%, on an average, the stock's return would go down by 2%. And a stock having beta 1 greater than 1 would be more volatile than the market, and if beta 1 is less than 1, the stock is less volatile than the overall market. And if beta 1 is equal to 0, the stock is losing money while overall market is gaining. When the market is going upwards, the particular stock would go downwards. Because we use sample data for regression analysis, so we will use the value of B1 as an estimate of stocks beta 1, and the coefficient of determination R square, which is also an important part of financial statistical analysis, would also be considered from the regression analysis. Let us work out what is the market model for Maruti Suzuki. So what we have done is, we've taken monthly return of Maruti Suzuki India Limited from January 2015 to May 2020, and for the overall market measured by Bombay Stock Exchange, which is known as Sensex, we've recorded both these data, and the market model was estimated using MS Excel for the sample data, and then the results were analyzed and interpreted. Let us see how we perform this analysis in MS Excel.
Okay, so we are here at the home page of the website of Bombay Stock Exchange. It is bseindia.com. So we will pull out the historical prices of Maruti Suzuki stocks and historical prices of BSE Sensex. So to do this, we click this markets and then market data, and you have a lot of historical information here about equity, about indices, public issues, listing, derivatives, etc. So we are interested into historical stock prices of Maruti Suzuki, so we click it, and we've decided to have monthly prices, so I click monthly. I enter the name of Maruti Suzuki India Limited here from January 2015. We've decided to have 5-year data. You can decide the time length as per your choice. So press submit. So you see you have a lot of data here. You can download this data in MS Excel also. So it looks like this. We are interested only in the month and closing price. And then we can download data for Sensex also. So we click market data again, and here in the tab of indices, we have indices historical prices. From here we select BSE Sensex period monthly from January 2015 and press submit. So here also you get a lot of data, open, high, low, close, etc., and press this to download the complete records. So you download it, and it looks like this: monthly open, high, low, close. Here also we are interested only in dates and the closing prices. So we have kept it in a separate Excel file like this, where we have months here in A, the data for Sensex here, Maruti Suzuki stock prices here. This RM we will calculate, which is return from market, and this R is return from Maruti Suzuki stock prices. So how we are going to calculate return is, so we are going to calculate return here, current month prices upon previous month prices minus 1. It would give you the return here, and we will convert it into percentage by clicking this, and we'll take it up to 2 decimal places. So when I copy it here, this gives me return of Maruti Suzuki stock prices also. And when we double click this small square, this would go till down. So here we have to delete this because there is no data after January 15. So you've got this. Now let us see how we are going to calculate beta out of these returns. So there are 2-3 methods. The first one is we'll calculate slope directly. Beta is nothing but slope. So equal to slope. So it asks known y's. So y is our dependent variable, that is our return from the Maruti Suzuki stocks. So we've selected this, comma, known x's. So we select the return from stock market, Sensex, as known x's, bracket close, and we press enter. So you have got the value of beta as 1.39. This shows that if the Sensex would go up by 1%, the Maruti Suzuki stocks would go up by 1.39%. And if Sensex would go down by 1%, it would go down on an average by 1.39%. Or in other words, if the Sensex return, it gives us return of 10%, it would give us return approximately of 13.9%. Now let us see another method using charts, how we can calculate it. So we can insert charts from here. So before inserting charts, we have to select the data. So we are selecting these two returns. We selected. So we want a scatter plot. So you can directly select the scatter plot from here, or you can select it from here also, from recommended charts. So this is our scatter plot of data. You could see it is showing linear relationship between returns of Maruti Suzuki and returns of stock market. Now to get the slope, what we could do is we have to just click any of the data point. We have to right click and click add trend line, and from here right hand you'll see that it shows by default linear. So just press display equation on chart. This would show you the beta value also, and display R squared value on the chart. So these values are here. So just see the beta value is again given the same 1.3977, and R square is 0.0564. As we know that beta value is measure of systematic risk and R square is measure of non-systematic risk or firm specific risk. The third method is we go to data analysis, and from here we will select regression. Press OK. So you have to input Y range here and X range here. Y range is the dependent variable, that is the return from stock prices, and X range is the return from Sensex. So I just press it, minimize it, and I select the return from stock prices, Maruti Suzuki stock prices. Just see that I am selecting R also. I'll tell you why. And then I am pressing this X and have selected return from X prices. And then we have to check this labels because we've selected R and RM also. If you will not check these labels and you will press OK, it will show you error. input range contains non-numeric data. So we press label and the output would be in a new worksheet. If you want output in the same worksheet here, you have to give output range wherever you want to get the output. So I'm getting new worksheet. I press OK. So you got this new worksheet here where you've got the regression output. Now you just see we are interested into this. This is your beta value 1.3977 and this is your R square value. So this is how we can calculate beta of any stock by using Excel.
So let us discuss about the interpretation of the output that we have received through analysis of the sample data of Maruti Suzuki and Sensex from MS Excel. So what we did actually was we performed regression analysis on the sample data of Maruti Suzuki stock returns and overall market return measured by Sensex. And from the point of view of the market model, in this regression output, we are particularly interested into the financial aspects of the process, which are especially B1 and R square. Our financial analysis from this regression output is particularly focused on these two statistics. So let us discuss about them one by one. First about slope coefficient B1. So what is B1? We call B1 as market related or systematic risk. So why we call it market related or systematic risk? Because it describes the volatility in the stock prices in relation to the overall market volatility. So in this case, just note that slope coefficient of B1 for Maruti Suzuki for the sample data is 1.39, or in other words, we call it beta of Maruti Suzuki is 1.39. So how we can interpret it? A simple interpretation is that for every 1% increase in the Sensex, the average increase in Maruti Suzuki would be 1.39%. Or let's take another example. If Sensex gives you 10% return, Maruti Suzuki is going to give you 13.9% return on an average. And same is applicable for the downfall in the market also. If the Sensex goes down by 1%, the Maruti Suzuki stocks they go down by 1.39%. The second measure that we are particularly interested into is coefficient of determination. So this R square, what it measures? It measures the percentage of total risk that is related to the market. So you could see that R square is 0.564, or in other words, what we can say is 56.4% of the variations in the return of Maruti Suzuki stock is explained by the variations in the return of Bombay Stock Exchange measured by Sensex. So the remaining 43.6%, we call it the risk which is not related to the market. Or in other words, it is the percentage of risk that is related to events specific to Maruti Suzuki. For example, the strategies or actions taken by Maruti Suzuki. So this we will call as firm specific risk or non-systematic risk. We've just discussed that beta 1 gives us market related risk, or beta 1 is also known as systematic risk. However, this R square gives us firm specific risk or non-systematic risk. Why we call it firm specific risk? Because it is attributable to variables and events not included in the market model. It is attributed to the actions of the firm or the strategies of the firm due to which the risk is created. So this is the proportion of risk that we could minimize by diversification. And how we can do that? You can achieve this by creating a portfolio of different stocks, of different companies. Please note that we cannot diversify the proportion of the risk that is market related. We can diversify the proportion of risk that is firm specific risk, that is non-systematic risk. So let us summarize the market model. Number one, we can estimate the beta of the portfolio. If you create a portfolio to minimize the firm specific risk, what you can do is you can estimate the beta of the portfolio by averaging the betas of different stocks in that portfolio. And if you are an investor and if you have indications to believe that market is going to rise, what you will do is you will be interested into a particular stock or a portfolio having beta greater than 1. And if you are a risk averse investor, or if you have enough information or knowledge to believe that the market would fall, you would be interested into a portfolio of stocks having beta less than 1. So to summarize the market model, we can say that return on a security depends on the return on the market portfolio and the extent of security's responsiveness as measured by beta. The return also depends on conditions that are unique to the firm. Thank you very much.